Hello and welcome back to Faceless Security, where we explore the world of technology and cybersecurity. Today, we will dive deeper into the data flow within an industrial control system, focusing on how process data is generated, used, and controlled to ensure efficient operations. Processes within an ICS are designed to transform upstream materials into more useful downstream products by altering their chemical or physical properties. Monitoring and controlling these changes require accurate and timely measurements of various process parameters, known as process data. Common sources of process data include measurements of flow, level, temperature, and pressure. However, many complex processes necessitate additional parameters. For instance, a water treatment plant must measure pH and turbidity along with flow, level, and pressure to produce clean water. Process data serve multiple purposes beyond mere control. Meeting regulatory requirements. Compliance with regulations is mandatory in many industries, and accurate process data ensures that the facility operates within legal and safety standards. Tracking energy costs. Process data help monitor and manage energy consumption, enabling cost savings and efficiency improvements. Providing design inputs for process enhancements. Analysis of process data can identify inefficiencies or areas for improvement, guiding capital investment decisions for upgrades. Controlling inventory and determining product pricing. Accurate data on process outputs aids in inventory management and helps set pricing strategies based on production costs and efficiencies. A typical ICS contains numerous control loops, human interfaces, and remote diagnostics and maintenance tools, all built using various network protocols on layered network architectures. This setup allows ICS support staff and vendors to access the system for diagnosing and correcting operational problems. The fundamental building block of ICS is the control loop or single-loop control, which is used to regulate the process. A control loop consists of several components working together to achieve and maintain a desired value of a system variable by manipulating another variable. Here's how it works. Sensor measurement. A field device sensor measures a physical property, for example, temperature, pressure, and sends this information as controlled variables to the controller. Controller interpretation. The controller interprets the signals and generates corresponding manipulated variables based on set points. This involves a decision-making process where the controller determines the appropriate response to maintain the desired conditions. Actuator response. The controller transmits these manipulated variables to actuators. For example, control valves, breakers, switches, motors, which then directly manipulate the control process based on the commands. Control can be fully automated or include human intervention. Additionally, control loops can be nested or cascading, offering better performance when multiple sensors measure conditions in a control process. For example, a cascade control system in a steam-supplied water heater uses a second controller to manipulate the valve opening based on measurements from a second sensor monitoring the steam flow rate. This allows for more precise control over the heating process, improving efficiency and product quality. The data flow through an ICS varies by vendor, topology, and protocols. The network, whether wired or wireless, links the ICS components. The human-machine interface, HMI, receives information from field controllers, relays it through communication protocols, and provides operators with a view of the process. Field devices. These include sensors and actuators that interact directly with the physical process. Sensors collect data on process variables, while actuators execute control commands from the controller. Field controllers. These devices, such as PLCs and RTUs, process the data from field devices and execute control algorithms. They convert analog signals from sensors into digital data and vice versa for actuators. HMI and SCADA systems. The HMI provides a user interface for operators to monitor and control the process. SCADA systems collect data from field controllers, display it to operators, and send control commands back to the controllers. Centralized control systems. These systems integrate data from multiple field controllers and provide a comprehensive view of the entire process. They can include advanced analytics, historical data storage, and remote access capabilities. In summary, understanding the flow of data within an ICS is crucial for maintaining efficient and secure industrial operations. Accurate process data is essential for control, regulatory compliance, and process improvements, while effective control loops ensure stable and responsive system performance. The integration of field devices, controllers, and centralized systems enables seamless data flow and robust control over industrial processes. Thank you for watching. Be sure to like, comment, and subscribe for more great content from Faceless Security.